Hey everyone, this is Mr. Wyrick, and I'm going to go through these notes for Thursday, the 3.14 arc lengths and sector areas. So this is actually really closely related to yesterday's lesson, if you're doing these sequentially. So yesterday what we looked at was some basic late elementary, junior high kind of stuff, finding the area of a circle, finding the circumference of a circle, and there's a reason we went back over that stuff. And the reason is so that we can do arc lengths and sector areas. Now, yesterday we really talked about exact answers and putting your answers in terms of pi, which is way easier than going decimals. And then, of course, the delta math for today wants you to estimate this to 2 decimal places. So you need to make sure you're looking at that stuff so that we can get that all put together. Okay, so here we are on slide 2, finding the area of a sector of a circle. And I have an illustration down in the lower right-hand corner that kind of lets you know what a sector is. So that highlighted area there. So what you do first is just do what you would normally do if you're trying to find the area of a circle. You go pi r squared. And this time, if you're using Desmos especially, I would kind of stay away from the iPhone calculator in this case, and go ahead and put pi. And I'm pretty sure that in Desmos, I'll test this right now. If you just type pi, it goes ahead and converts it to the pi symbol. I don't want you to use 3.14. You'll try to round too early, and it can make you get the wrong answer, and nobody wants to do this multiple times, okay? So use that pi symbol. So you'll go pi times the radius squared. And then once you have that, you need to figure out how much of the circle you have, and this is where you bring the angles into it. So if this is a 60-degree angle, it's 60 over 360 that you are going to multiply that by, because that is going to break it down into the portion of the circle that you have. Now, if you know how to reduce this already, like 60 out of 360, you don't need to type that 0. You could put 6 out of 36. And if you're quick at reducing fractions, you could already have that as 1/6. But if you don't want to do any of that, or if you're worried that you're going to make a mistake mathematically somewhere in there, you can just type into the calculator that exact 60 divided by 360. So I would need to do pi times the radius squared, and then I multiply by the angle that I have, that 60 degrees, and then I divide by the full 360, okay? So that's going to multiply your area by the portion of what you have, and it should reduce it to just that sector of the circle and give you the area. There's a couple of samples on that next page. So there's our 60-degree angle. So this would be 10 squared times pi, so 100 pi. Or you could type it in as 10 squared pi, and then you multiply by 60 and divide by 360. On the next one, the one that's labeled as number 14, we would do 3 squared times pi multiplied by 150 and then divide by 360. Okay, so again, if I do that in Desmos, let me just type that in real quick. So 3 squared times, and again, you can type pi for pi, or there is a pi button on the Desmos keyboard, and then we're multiplying that by 150 because that's the degrees that we have, and then dividing by 360 because it's out of the full circle. I got 11.7809, and I believe the whole time you're rounding to the nearest hundredth, so that would be just 11.78. Remember, when it's 2 decimal places, you look at that third decimal place. If it's 5 or above, you round up. If it's not, you leave it where it is. Okay, so that's finding the area of a sector. The fourth slide talks about the length of an arc. Now, don't forget, this is talking about length of an arc as opposed to like the size of the arc. The size of the arc we measure in degrees, so 360 degrees all the way around the circle. This is not where we're measuring in degrees. This is where we're finding like how long it would be for walking around that. So if you're like running around the outside of a merry-go-round, you could calculate like how far that is, or how far it is to go part of that circle. If you find one of the roundabouts in town, you could figure out how far you're driving, okay? So on this, it's a similar kind of thing. We are going to find the circumference, which is 2 pi r, or pi times the diameter. And then again, you multiply by the portion of the circle that you have. So you are going to need the degrees for that part. So again, if we have like a 45-degree angle, that's 45 divided by 360. So on our practice problems, the very first one, we have an 11-foot radius. So that would be 11 times 2 times pi. And then we multiply that by 315 divided by 360 to get how far it is around that arc, as opposed to the distance around the entire circle that we were finding with circumference. For number 2, again, I'll go ahead and put this one in Desmos. My radius is 13. So it's going to be 13 times 2 times pi. And that gives me my circumference, or the decimal approximation of my circumference. And then I'm going to multiply that by 270 degrees, because that's how big my sector is, or my arc is, and then divide that by 360 degrees, the full circle. So I get 61.261. So that's going to stay at 61.26. Hopefully that'll help guide you through this set of notes, through the assignment. There's 2 parts. One part is just find the area of a sector. One part is just finding the length of the arc. So make sure you do both of those. And good luck. We'll see you on Friday. Don't forget, we do have the performance task on Friday, so be ready for that.